All right, so this is LabVIEW, a graphical programming language, high-level programming language, where we use objects to program, all right, rather than actual code. Now the students can use this to do many things: plant operations, you name it, robotics. This particular example showcases a code for an application to control a servo motor or servo motor. And this servo motor has many applications. It is a bidirectional motor, meaning it can go both forward and reverse. It is used highly in mechatronics for actuators. It is used in robotics as well for actuators and sensors. And this is an example of that. Now we're using pulse width modulation. All of these components are a part of the new Industry 4.0. And these are things that we'll be using as we progress as a world, as a planet. This is my RIO from National Instrument. It has the capability to output signal in the form of pulse width modulation. This pulse width modulation is then used to control the servo motor and to determine the direction as well. This is the application here. We set the PWM channel, pulse width modulation channel, here, and then we perform an operation, a mathematical operation, and then we put an output to the servo motor. And if we run this, we see here, this software also gives us the graphical tools necessary to control the servo motor. And if we wanted to go forward, we can adjust the position. Sorry. We can adjust the position using this dial. If you look. Alright. So we can adjust the position and go forward. We can also stop the motor from the control panel. So we are at 0 position, and we can also go reverse and change the direction of spin of the motor. This particular servo motor is used for our robot, in terms of our course delivery. We use this to demonstrate different functions, such as moving a camera. We may mount this camera on the robot and want to move it up and down. So we use that on a linear guide system or a linear motion system, such as a rack and pinion or lead screw or belt driven or chain driven system. We can adjust the height of this camera. We can also use it to control an arm, in terms of pivoting that arm to different degrees. And as a part of our overall delivery, we do all of these in the sense of programming the servo motor and connecting it up to the RIO and actually interfacing with it via the LabVIEW software. These are our aluminum metal rails that we use to assemble the base and the structural components of the robot. They are so designed as to be easy to assemble. The holes match up perfectly and enable you to perform to create different structures, different type structures. We also have our DC motors for high torque. These are preferred over the servo motors because they have a higher amount of torque. We also have our Omni wheels, which can go multiple directions. These allow the robot to move diagonally, and then we can also move forward and back. we have our battery pack as part of powering our wheels. We can power them simply by connecting them. You can power them simply by connecting them to the battery and we achieve motion. If you want to change direction, all we have to do is simply connect it in the reverse.